All right, it's a little rainy out. It's definitely a little windy out, but let's have a little flight here, see what we can do. In front of my house, little Iflight.
Engine off.
And that's the end of that. I figured while I'm in the process of making videos, might as well do a repair video. In that crash you just seen, I'll show you what happened here, which happens a lot. Let me just set everything up. You'll see. You see motor. What is that? That's motor. Let's see. Motor 2. I hit the branch with motor 2, and the one downside to micros is that, you know, if your props are spun up and you hit something, there's a good chance that you're gonna burn a motor out. I don't know if you could see it from there, but you can see the windings are all black, and it has a smell to it, a burnt electronic smell. I always smell my motors after a crash because just because they're spinning doesn't mean they weren't damaged. This one in the previous crash, the windings were a little dark, and it had a smell to it, that burnt electric smell, and this crash is what did it in. But it's good to check your motors, and just because they're spinning doesn't mean that they're not 100%. Because what could happen to you is you could be flying after a crash, and you could have windings that are black like that, and you know, they show signs of being burnt, but the motor will still work. But what'll happen is you'll go to do a move, whether it's a punch out or you could just even be flying regular flight, just flying in a straight line, and the motor will give out on you. So you know, it's good to change the motors when they hit that point if you're going to be flying in areas that you have, you know, the potential of losing your quad, or of course, if there's people around. You shouldn't be flying around people anyway, but definitely always check your motors. So this one burnt out, so I'm just going to do a quick motor swap. I buy a bunch of motors at a time. These are the Zing, these are the 1206s right here, 6500 kV, which is these purple motors right here. And I always buy an extra set because they tend to burn out faster than 5-inch motors. And it's good to have them on hand so you can get back up in the air. So we're going to do a quick repair, and I'm going to speed it up. You can see now, if you could get a close look at that, you can see how the windings are black. And that's what a burnt motor looks like. As you see, my VTX is double-sided tape to the top of the top plate. Take a pair of 45 tweezers and just pull that out nice and easy. And now's a good time to show what this looks like, what a neat build looks like. And this is why my signal is so good. Because number one, you know, this CL Racing is an excellent board. It's got a nice layout with the VTX in the back and the camera in the front. And the shortest possible wires from each component. So from the camera to the flight controller, you got about a ½ inch there worth of winded up wire. Always twist the wires so they create a shield against interference on both the camera and the VTX, as you see here. And that's what a clean setup looks like. So that's what you want, the shortest possible distance from your flight controller to your component. The more wire you have, the more noise you're going to get. It's not really necessary. This is for my receiver, my Crossfire. You don't have to do it with that. You can, but it's not mandatory because there's no video signal going through there. That's just your signal, which the latency is going to be the same no matter what. So this particular stack, the ESC, is spun 90 degrees. So the pads are inside the frame as opposed to the outside of the frame. As you can see on standard setup, the pads would be here. They're not. They're on the front and back of the quad. So being that's the case, it's a little bit more work to change a motor, but no big deal. I don't mind. So what I do is I open it up, I pull the camera out, and I expose the wire here for to be taken out. And that's pretty much it. So this is another reason why I like to use zip ties instead of electric tape, because it's a lot neater. You find that you change motors on the little builds a lot more so than the 5-inch build. So instead of unwinding all that tape and making a mess, you just pop off the zip tie and replace it when you're done. And it's that simple. So now we're just going to take these wires and we're going to expose them a little bit, as you see right there. And these are the wires that we're changing. So I'm going to heat up my iron. I'm going to turn on my fan. It's going to get a little noisy, so I'll probably voice over this in a video. I'm going to turn on my iron. Before I turn on my iron though, I'm going to turn this fan off for now actually. Alright, now this is the tip I was using to do my XT60 on my 5-inch, too big. Very important when you're soldering. Use a tip that's appropriate for the job that you're doing. So, small quad like this, little motor pads, you don't want to use a tip like that. So I got a whole bunch of extra tips here. And job like this, you want to use the small flathead. The smallest flathead, like this one here. It's much more practical because it fits, you know, it fits pretty well on the pads. You're not heating up everything around it. You know, so it targets the area that you're soldering as opposed to heating up all the surrounding pads, which is never good. Heat is always bad. You want to have the least amount of heat as short of a time as possible. All right, so I'm gonna heat up my iron. I'll be right back. Okay. So my iron is close to temperature here. I'm going to prop this up so you guys can see what I'm doing here. All right. This is one easy way to do it. I'm just doing this for you guys so you can see what I'm doing. Okay. And actually, since I'm right-handed, I'm going to switch this around like this because I hold the iron with my right hand. This is actually the best way to do it for me. Okay. Most important part when you're soldering is to set yourself up so you don't have to juggle things around when you got the iron in your hand. So like right now, as I'm about to do this, I can see right away that I'm in danger of melting this propeller. So before I do anything, I'm going to take this propeller off just to save myself the headache later. Okay, now, see how I have an open shot to my motor wires here? When you're dealing with small quads like this, you know, accuracy and precision is the most important thing. So, I'm set up here, I'm ready to go. One wire at a time, start from the furthest away. See the nice little light tap there? That's it, done. Okay, so now that that's pulled away, the next thing that I do here, just because it's good practice, is you take your flux pen, okay, and you just touch each pad with the flux pen, and then come back to the pad, and you freshen it up just a touch. I keep my solder underneath here on a spool, right, so you don't waste any solder, and just give it a little, nice. See how shiny that is now? 1, 2, and try to stay away from that other motor pad. 3. So you see how nice and clean that is. Those solder pads, they're pre-tinned nice, and there's more flux in there now, and that's important. So now all we got to do is just take off this motor since it is desoldered. Being that it's the windings that burnt out and this bell is still straight, and I could tell by looking at the stator to the magnets, you can see that there's no wobble. I'm going to save this bell because a lot of times you crash and your stator will still be good, but you bend your bell. So instead of replacing the whole motor, I now have an extra bell that I could use. Not only the bell, I also have the C-clamp and these bearings in here, which also, they go also if you crash in sand or something like that. you destroy these bearings right away. So it's always good to save the motors because there will be usable parts on these motors. So just because you have a bunch of them doesn't mean you should waste material. Okay, let's take the new motor. All right, we leave the one screw in so it's nice and easy to get these motors on. See how nice and easy that was? Prepped. Screws are prepped with the Loctite, so you just drop those right in like this. Okay, it's 2 and 3. I run 3 screws on this because that's all you really need. It's a very small quad. Okay, and I'm not using the electronic motor on this screwdriver. I'm just tightening it by hand. Otherwise, you'll strip the screws out. So that's done. Next thing we do is now we're going to measure these wires and cut them one by one. But first, we are going to put a zip tie. See, I have everything nice and organized. It's good. You don't have to search for everything. You just pull out as you go. I'll show you. Gives you a shot of my little setup over here. Okay, so now I always do this the same way. I put the zip ties towards the center, middle, inside the knobs like that. See, always going towards the inside. Not that it matters. I just I like it like that. It's nice and neat. I just got into a habit of doing that. So okay, that's it. Just like that. And we do that so we don't have to worry about cutting the wires too short. Okay? So now, make it so you guys can see. Okay? So now what we do is, one by one, we measure the wires and we cut them according to their length. So if I always wire mine straight to the pad. So when I remap them, when I change the direction in BL Heli, I know I don't have to do that again, because if I put them back exactly the way they were, then I know that they're going to be spinning in the right direction. But of course, we'll test that before we fly, just to be safe. But there's your length right there. So cut the first wire. Okay. Second wire, same thing. We are going to make sure that the length is correct. Go into the second pad, right about there. You leave yourself a little bit extra. It's 2. And the third one goes to the last pad. And we are also going to make sure we have a little extra. And that looks good right there. I'm going to cut this one on top of the tweezer. So add a little bit extra. Okay, so now, being their silicone wires, all you got to do is pull off. You can pull it off with your fingers, but if you're very gentle, you could do it with these two, which I know how to be gentle, so I could do it with these. But if you don't feel comfortable using these cutters, you could, easily cut these wires down short if you use these. So, I mean, if you feel more comfortable using your fingers, then use your fingers, because it takes a little bit of experience to do it this way. Okay, so now that all 3 of those are stripped, they're very small wires. So you have 2 different types of flux that you could put on wire. This is the one we're going to use right now. This is the gel, which is very malleable, and it's good for little tiny wires like this, because you could literally just take anything, dip it in, and just dab the wires like that, That adds flux, which will make the solder tin much better on these wires. It's not a must, but I would recommend doing it, because solder itself has flux in it, so it will bond regardless, but it's good practice to do that, so you know that you're getting good saturation into the wire strands. And this is the other type of flux. This is paste. This is good for heavier gauge wires and other components that you need to flux before you know, before soldering. It's all only used for wires. It's the only thing I use these for. Any pads, I always use the pen. The pen is a liquid, and it's very easy. You just write on whatever you're doing, and you're done. You could do it. You could use the pen for this too. You could just tap it like that. But you know, it's all up to you. Whatever you want to do. So now that that's done, we are going to just pre-tin these wires. Nice and easy, just like that. 2 and 3. I turn on my fan. Forgive me if it's a little louder, but that's how it goes when you're soldering. Okay, so now I'm going to turn it this way just to make it a little easier for me. Okay, and now before we touch the iron onto the pads, we got to prep, set up first. Okay, so you want to bend the wire to where you're going, so you're just dropping directly on. See how nice and easy that is? Make sure you clean the tip of your soldering iron. Okay, and then you just tap. It's that easy. See how nice and easy that was? And that's a nice clean solder joint right there. Same thing, you bend the wire so it's where you want it to be. So all you have to do is just tap your pad just like that, and you're done. And the third one, same thing. You bend it, and you just tap, and you're done. And just like that, we change the motor on our quad. Turn off the fan. Oh. And as you see, I run my solder underneath the desk. You don't waste any. Like this, I got it on a little spool, and I just pull it as I need it and retract it when I'm done. And that's how I keep my solder nice and neat. So if you take a look here, you could see these 3 pads. If you look, you can see this, the motor that was existing already. Those joints are not terrible, but I was in the middle at the end of the build, and I kind of rushed through it, and you can see they're not nearly as clean as those because I didn't tin them. I just rushed through it, and it's passable, but you can see how much cleaner the new motor looks as opposed to motor 4. This is motor 2, this is motor 4, and you can see the difference. It's visible which joints are better. I could fix that right now, actually, just by, if you want to fix joints like that, it's a good opportunity to show you. What you do is you just add a little bit of flux. Flux is always the key ingredient to good solder joints. Just like that. And then all you got to do is make sure you hold the wires in place so you don't lose the pad as you do it. But all you have to do is just tap, tap, and tap. Just like that. It was all over. Here is my camera. It's going to fall right back into place. If you see, I put a couple of pieces of electric tape in the grooves there, and that's because over time, even though it's nice and tight when you first build it, the camera plates to the bottom plate, over time, crashes, vibration, it loosens up and it will cause jello. So, little pro tip, just stuff tape in there. Make it nice and snug, and you get no vibration in there. You eliminate those little harmonics. And I do the same thing on the top plate, but not in the grooves. I push the bottom portion of the camera plate right here. Has something to grab onto as well, so it stops vibration on the upper end as well. So before we go any further, let's make sure we plug everything in. Okay. Camera. Make sure you twist it in the tightening direction, not the loosening direction, so your wind stays nice and tight. Okay, my camera is back in. My receiver is in a good spot, like that. Okay, now next is my VTX, and it's always easier to do this before you put your top plate back on. So it goes in this orientation here, and just like we do when we solder, we line it up like this. Okay, and now that it's in position, just pop it right in place like that. It's that simple, see? So once you get used to working with the smaller quads, it becomes a lot easier. First building them is very tough. Smaller the quad, the harder the build. It's just a fact, because everything is a lot smaller. But once you get good at it, once you practice at it, you just get better and better at it. So don't get discouraged when you're first building. It takes time, but you'll get it. Okay. This is also a 3D printed mount that I made to pass the antenna up through the top plate and to give a separation from my battery line and from my L setup in the back. I made this, I fabricated, it's on Tinkercad. If you want a link to this, just leave a message in the description and I'll give you a link to it. It's a private file, but I'll share it with you guys, not a problem. Okay, that's that. And this is also a private file. I got the antenna tubing off of Amazon, and this file I made myself. It basically just slides right over the rear standoff, and it's got a 90-degree. These are a little bent up, but you can see there's pretty much exactly 90 degrees, which is how the antenna is supposed to be mounted. And then I hot glued it. The hot glue after crashes is loosened up, so I could peel this away and re-glue it. I'm going to probably do that right now, actually. So it basically just keeps it locked in place when you hot glue it, but it also is soft enough where it'll break loose without breaking your print. So this is a PLA print. You could probably get away with using TPU, but PLA is what I had at the time I printed it. I'm going to probably use TPU and remake it because I have TPU now. I was out of filament at the time I made this video, but okay, as you see now, once you peel off the glue, that's what it looks like. It's just two holders for either antenna tube, holding them at a 45-degree angle, and that's it. It's very practical. It's kind of awkward mounting these on here without doing this because you have a center rear standoff, so you can't go straight up and this way, in other words, vertical, you know, with one antenna up and one straight back, because it interferes with your VTX antenna. So that's why I made it like this, and it's underneath the motor bells, so it doesn't get hit ever, really, prop strikes. I'm sure in some awkward way, if you crash like that, whatever, it would happen, but I haven't had any issues with it so far, so I would recommend you do it if you're building this exact frame. I'll give you the file for it. Screwdriver takes forever. All right, so that's that. And now for the moment of truth. Let's do a motor test. Okay, so let's plug in. I trust my building enough where I didn't have to do a smoke test, but I would recommend you do a smoke test. Okay, and they are spinning in the right direction. All right, for the test flight. And you can see how nice and smooth this thing flies. I love this quad. A little 2-inch quad, it flies like a 5-inch, you know? Got a lot of hang time and just a lot of fun to fly. So, see, punch out nice and smooth, no prop wash, 2-inch drones. And I like to say it's because I'm such a good tuner, but truth is, it's just better flight has become so good that with the RPM filters, I mean, you can make anything fly good, I think. But this little 2-inch ripper, man, you can fly it anywhere. See, this is right in front of my house. This is where I attempted to fly earlier when I crashed and smoked my motor. But this is a nice little spot because it's got a lot of ins and outs. Like you see over here, like got a lot of foliage. Then in front of the church over here, get nice and low and hit all these little gaps. Nice. Oh, there's a wire there. Yeah, so it's flying good. I'll put my rates up so you can see what they are, but so you have an idea. All fixed and repaired, flying very nice. Ooh, windy.
Engine off.
And job well done. Thanks for watching, guys.